When you're building an RF lab, one of the most essential pieces of equipment that you need in that lab is a signal generator. And historically, we at Keysight have had really nice and also kind of expensive signal generators. But now we have the compact signal generator family. And the point of this is to be a portable, lightweight, super high quality signal. So it's not going to do advanced like QAM modulation, but it is going to do some of your fundamental modulations. And it's also going to be a super clean continuous wave signal. And I'd like to see that in action. So for that, I'm joined by Kevin Trout. Kevin, thanks for being here today.
Yeah, glad to be here, Daniel. Thanks for having me.
So talk me through what we're set up with here.
Sure. So what we've got here is the AP5001A. It's our new compact signal generator. And what we have is it's connected down here to a CXA 9000. So with the compact generator, we're outputting a 1 gigahertz signal, CW, at 0 dBm output power, and we're routing that into the signal analyzer. And what you can see down here on the screen is that CW tone. And I went ahead and set the span so you could see the tone nicely, and then I adjusted the resolution bandwidth of the signal analyzer, which allows you to really increase the granularity of the signal that you're looking at, and it'll drop the noise floor. And what that shows is it shows as you continue to drop that noise floor, typically all generators would have spurs, different distortion products that will show up in the noise floor. But what you can see here with this compact generator is as I've dropped the noise floor by decreasing the res bandwidth, the noise floor is down about 90 dBc below the carrier. And you can see on the screen there that the signal is very clean. There's no phase noise side lobes on it. You don't see any spurs or distortion products. So just by doing that simple test, you can get a sense of the quality of the signal purity and the signal quality capability of your analog generator. And that signal purity and signal quality is very important for engineers because if they're using this generator as a lower cost LO, right, like you mentioned before, people don't always need the full, very expensive, very heavy analog generator, where if they can get a lower cost, smaller one, but still create a very pure signal, as you see there on the screen, they can use that as an LO substitute to feed their converter if they're testing a down converter, for example. And by having a very clean source as the LO, they're not going to have feed through of those distortion products into their converter and into their mess up their test, right? So with this, you've got a deterministic, very controllable, very clean analog generator to do that kind of work. But again, very low cost, very small. This thing weighs about 8 pounds and very easy to lug around the lab.
So we're not seeing any major or significant spurs on this at all. There's no distortion like you talked about. Why does that matter when you're going into testing a system? What would additional distortion, some of those lobes or some of these spurs, what sort of havoc could that cause to your tests? And is it going to potentially mess you up in the long run?
Sure. No, it's a great question. So when engineers are using signal generators to test their devices, they want to test the capability of the device itself, their device. They don't want to be worrying about what is the contribution of the test instrument to their device setup. So if you have an application maybe like radar, where they're dealing with very low power radar returns in their receiver or something, you don't want to confuse any distortion products that are feeding through from the generator with your other signals that are of interest that are also small. So if you can get a very clean, pure source to test their device, that minimizes the chance of our test instrument contributing misinformation or worsening the result or creating confusion on, if they're looking at their device and they're seeing some little tone or spur or something, did my device make that tone or did the generator make that tone, right? So the cleaner source that we can give them, the more likely or the more confidence they're going to have that the stuff they're seeing is really their device response, their device performance.
And those little, surprise tones can really cause issues when it comes to compliance and looking at, adjacent channel power or FCC limits even. You have to know what's causing those signals and where they're coming from, and you don't want it to be your signal generator.
Right. It just takes that variable out of the equation, right? If you can provide a very deterministic, clean source that's controllable, you don't have to worry about its contribution to what you're doing, especially if you're working with low-level signals in your device test.
Learn more at keysight.com/find/signal generators.